Bismillahirrahmanirrahim. In this lecture, we are solving example 5.6 from the thermodynamics. So, statement of the example is a cylinder fitted with a piston has a volume of 0.01 meter cube. So, in given data, total volume V1 is equal to 0.1 meter cube and contains 0.5 kilogram of steam. Mass of steam is 0.5 kg at a pressure of 0.4 megapascal. 0.4 megapascal, which is equal to 400 kilopascal. Heat is transferred to the steam until the temperature is 300. It means that the final temperature is 300 degrees centigrade, while the pressure remains constant. This is constant pressure process. P1 is equal to P2 is equal to P is equal to 400 kilopascal. Determine the heat transfer and the work done for this process. So this is the required data. Now we start solution. In solution, first we draw PV and TS diagram. So first check where the first state point is in wet region or in superheated region. So for this we found Vg. So first we find specific volume. This is total volume and mass is given to us. So we can find specific volume V1 is equal to total volume divided by mass. Total volume is 0.1 meter cube and mass is 0.5 kg, which is equal to 0.2 meter cube per kg. So now we find Vg from saturated steam table at pressure is equal to 400 kilopascal. Vg is equal to 0.46246 meter cube per kg, and the value of V1 is smaller than this value. It means that V1 state 1 is in wet region, is the value of V is less than Vg. So steam at state 1 is in wet region. Now we check state 2. So for state 2 we check superheated saturated temperature. So from saturated steam table at pressure is equal to pressure is constant, P1 is equal to P2. Saturation temperature is equal to 143.62 and the temperature given to us is 300 degrees centigrade. It greater than TS, greater than TS. So steam at state 2 is in superheated region because the temperature given to us is more than saturation temperature. So now we can draw PV and TS diagram. This is pressure in kilopascal, temperature volume in meter cube per kg, and on TS diagram temperature in degree centigrade and entropy in kilojoule per kilogram per Kelvin. This is the saturation curve on TS diagram and this is the saturation curve on TS, and this is on PV. On PV diagram, constant temperature line is this: P1 is equal to P2 is equal to 400 kilopascal. Found one, state 1 is in wet region and state 2 is in superheated region. So this is the uh, constant pressure line. An area under the curve on constant pressure on PV diagram is work. Similarly, constant pressure line on TS diagram is this. This is point 1 in wet region and this is state 2 in superheated region, and in this area represent heat Q. Area under the curve on TS diagram is Q. So as we know that W is equal to M, mass is given to us, so we use word mass. So we use here mass. M integral of 1 to 2 P dV. So W is equal to M, P is constant, and integral of dV is equal to V. Lower limit is V1, upper limit is V2. So MP upper limit minus lower limit. So V1 is given to us, mass and pressure is given to us. We have to find V2. So and point 2 is in superheated region. So for superheated steam table, from superheated steam table, at P2 is equal to 400 kilopascal and T2 is equal to 300 degrees centigrade. V2 is equal to 0.65484 meter cube per kg. So put the values and equation of work. So work is equal to MP V2 minus V1. The value of M is 0.5 kilogram. Pressure is 400 kilopascal. And V2 is equal to 0.65484 minus V1 is equal to 0.2, and the value of volume is unit of volume is meter cube per kg. This kg will be cancelled with this kg. Kilopascal, we can write Pascal in as Newton per square meter. So meter square will be cancelled with 2 meter, 1 meter will be left. So W is equal to 0.5 multiplied by 400 multiplied by this difference of this value. So the final answer of the W is equal to 90.968 kilojoule. Newton meter is equal to joule. Positive sign mean that work done by the system or work output according to the convention of this book. Now we are finding Q. So from heat transfer, so from first law of thermodynamics, Q minus W is equal to M U2 minus U1. So Q is equal to M into U2 minus U1 plus W. So first we are finding U1 and U2. U1 is in wet region, and as U1 is equal to UF plus X UG minus UF, and formula for V1 is equal to VF plus X VG minus VF. So from second formula first we find X, and then from U1 formula we found U1. So from saturated steam table at P1 is equal to 400 kilopascal, V1 is equal to This is Vf is equal to, Vf is equal to 0.001084, 0.001084 meter cube per kg, and Vg is equal to 0.46246 meter cube per kg, and Uf is equal to 604.29 kilojoule per kg, and Ug is equal to 2553.55 2553.55 kilojoule per kg. Now from V1 equation we are finding x. V1 is 0.2 meter cube per kg is equal to Vf is 0.001084 meter cube per kg plus x Vg minus Vf. Vg is 0.46246 meter cube per kg minus 0.001084 meter cube per kg. All values are known to us, only calculation. So find x, which is equal to 0.4311. Now put value in the equation of u1, in the equation of u1 to find u1. So u1 is equal to uf is 604.29 kilojoule per kg plus x is equal to 0.4311, and ug minus uf 2553.55 minus 604.29 kilojoule per kg. So u1 is equal to 1444.61 kilojoule per kg. This is simple calculation, you can calculate this video. Now to find u2, use the superheated steam table, because state 2 is in superheated region. So from superheated steam table, at pressure is equal to 400 kilopascal and temperature is equal to 300 degrees centigrade. u2 is equal to 2804.81 kilojoule per kilogram. Now we can use the heat transfer from the equation already discussed above, plus W. So Q is equal to 0.5 kg and U2 is 2804.81 minus U1 is 1444.61 kilojoule per kg. This kg will be cancelled with this kg, plus W. The value of W is 90.968 kilojoule. So Q is equal to 770.968 kilojoule, and this is the final answer of heat. The value of Q is positive, it means that heat supplied. So this is the final answer, and for more videos please like and subscribe my YouTube channel and share with your friends. Thank you.